I'll turn it over to you.
All right.
And so, ladies and gentlemen, John Weide on Quartz.
Yep. So I taught at Mesa Community for about 20 years, along with Ray Grant, and I'm teaching right now with Kelly Wakefield. Well, I guess I am. I'm not sure. I'm not there anymore, so we're doing everything online. But I'm retired, and I'm still teaching part-time, and I'm busy. Just like Ray Grant said, you get busier when you retire. And I agree with him now. So anyway, I'm going to talk about quartz crystals. It's all Ray's fault, because going along looking for minerals with him, I decided I need to specialize in something. And so I decided, hey, quartz is pretty easy to find. I'll specialize in that. So this is almost everything I'm showing you here is things that I have, not necessarily collected. Oh, I collected them like at the flag show and places like that. But I'll tell you the ones that I actually collected in the field. So this is a scepter from, oh my God, I think it's Crown King, but I'm not sure. So I'll start going now through it. I apologize for the way some of the movies are going, because I had to refigure most of the movies, the videos, and they don't work as good as they used to. Anyway, I'm going to talk about general information, quartz crystal structures, twinning, inclusions, crystal forms, massive forms, synthetic fake crystals, and unusual crystals. So composition of the Earth is about 47.2% oxygen and 28% silicon, and that translates into the possibility of about 60% silicon dioxide on Earth. SiO2. All right, formation of quartz crystals. Probably the major one to get crystals is from the precipitation out of colloidal material of a supersaturated solution of silica gel. Here's the formula. And really what that's saying, orthoclase, when you act on it with water and carbon dioxide, gives you clay, potassium carbonate, and silica. That's one of the reasons you probably find many quartz crystals in clay. Another place is when you look at massive quartz, it comes from the crystallization of the solidification of molten magma. And then other crystal growth is due to the sublimation of silica from the liquid phase. That's like Drusy Quartz. Crystal structures, crystal shape, symmetry, enantiomorphism, and twinning. So basically what we have is a hexagonal prism, has 120 degrees angle on it with each of the sides. And even when it is distorted, those angles are still 120 degrees. So the prism is topped by a pyramid, six-sided pyramid. The faces may be equal, but they're usually not. Very seldom do you ever get a perfect quartz crystal. They do have some constant angles, like the angle between the faces is 142 degrees, and the angle with the faces and the actual hexagonal prism is 38 degrees. Now it has symmetry down the C-axis. That's a long piece of the quartz crystal, and it's threefold symmetry. In other words, I look at A1 here, and I can rotate it all the way over to A2, and then rotate it to A3, and all three of those should be the same if the crystal's perfect, obviously. It has three polar axis, A-axis symmetries that are twofold, and they're perpendicular to the hexagonal crystal. Again, we're talking about a perfect crystal. It has to be doubly terminated, and all the faces look good. Then you can rotate it 180 degrees, and it should repeat itself. There's no center of symmetry, nor is there a plane of symmetry. So enantiomers. So I'm into collecting a lot of the weird stuff here. And so the first thing I'm looking for is left-handed quartz crystal. Notice the beveled edge on the top left-hand corner. And then on the next face coming over, it's on the lower right-hand corner. Then the next face, it's on the upper left-hand corner. You can actually get a mirror image of this. That's called a right-handed quartz crystal. It's on the top right-hand corner, then the lower left-hand corner of the next face, and then the top right-hand corner of the next face. That should be pretty obvious to everybody. So those things, those two crystals, right and left-handed, do not repeat themselves. You can't turn one onto the other one. So if I take this, and this is a right-handed quartz crystal, I rotate it 90 degrees. Watch the red. I rotate it another 90 degrees, and it's in the top right-hand corner. And if I rotate it 60 degrees around the C-axis, it looks exactly like the first one. So a right-handed quartz crystal, whether you're looking at it at the top or you turn the bottom up to the top, they both should look the same. So after I worked on these, got these refigured, I lost the top of my crystal here, but you can kind of still see it. On these 6 pictures down here in pink, that shows the faces. And you can, I think you can see all 3 of those. So the first one is that one right there. And then there's nothing. Then the next one right there. And then the next one's nothing. Whoops. And then the last one's right up in the corner. You just barely see it right there. So that was a left-handed. So here's a right-handed. Again, I marked them. And you can kind of see them. I lost the top of the crystal again. So there's the first one, nothing. The second one, nothing. And the third one. They're on the top right-hand corner. Twinning. All right, so now it's getting more fun. So we can have twins that are parallel axis twins. Both of these are along the C-axis. We can have what we call they're called penetration twins. We can have the Dauphine Law, the Brazil Law, or the combined law. So let's go for it. Then we have inclined axis, which are contact twins. In other words, two C-axes are at an angle to each other. All right, so this is the Dauphine Law twinning, and notice that the one on the left is a left-handed, and it's not just every other face, it's every face has a beveled edge on the top left-hand side and the bottom right-hand side. And on the other one, okay, I just had someone call me. I don't know who it was. Spam. Top right-hand corner, maybe it's someone saying that you can't get in, or in other words, I'm lost. Top right-hand corner, beveled edge. Lower left-hand corner, beveled edge. Right and left-handed Dauphine twins. So here's the Dauphine twin, left-handed. Notice that it has a beveled edge on the top left-hand corner of the first face, left-hand corner of the second face. This crystal is really, really ugly. A lot of my crystals are really, really ugly, but they show what I'm interested in. And here's an example of a left-handed twin where it's on the top left-hand side and the bottom right-hand side of the same face. Okay, and then I think I have one here. Let's see what happens on this one. Left-handed. Left-handed, if you got 2 faces in a row, that can't even see anything there. Now there's a little bit there, and there's a little bit there. So if you get more than 2 or 3 of them, then you've got, particularly if you got 2 in a row, that's a left-handed Dauphine twin. So here's a right-handed Dauphine twin. This on the right, this is what the crystal looks like at the top. I mean, it's been smashed up and everything, but it shows what I'm interested in. So I'll click this one. So right-handed, little bitty beveled edge, a better beveled edge, another beveled edge, 3 in a row, 4 in a row. Oh my gosh. I got 4 in a row. Might have been 5. I'm not sure.
John, we have a question.
Yes.
How rare is it to find these Dauphine twins?
They're not too bad. You can find the Dauphine twins. Wait till I go on to the next one. They're pretty rare. I'm glad you said something. Every once in a while, ask me a question so I know that I haven't disappeared. I'd appreciate that. Yeah, these Dauphine twins are pretty common. Matter of fact, Ray gave me a picture, and I'm going to show it at the end. It's not my Dauphine twin. I'd like to have it, but it belongs in someone else's collection. All right, so this is the Brazil Law. Now, these are getting more difficult. These are difficult to find. I've got 2 of these, and they're not good at all. So anyway, what happens is a left and a right-handedness get together on the C-axis. So I've got a little picture thing here. I'll do that again. A right-handed is pushed onto a left-handed, and then get a Brazil twin. Now watch it. The top was left-handed onto a right-handed. Okay. I think I got them labeled wrong now. Right-handed plus left-handed. Yeah, they're labeled opposite. I'll have to fix that. I didn't look at that part. I just knew it did what it was supposed to. All right, so here's one. Look at this is the only face that shows it. That little spot right there, and that little spot right on both of the top right and left hand corners. Brazil twin. And here's another one. I've got a story about this one. My ex and I she wanted to go to Hobby Lobby, and I got bored, so I went over to their pile of quartz crystals for kids, and I went through the whole pile. I found this one in that pile. So this is a Brazil Law. Combined Law. Now this one I have one of, and it's the only one I've ever seen. So I'm sure they exist, but I don't. This is the only one I've got. So anyway, this one, you get the top and the top left hand and top bottom there on the bottom left, and then on the next one is top right, bottom right. So let's do that one. So I got a right-handed and a left-handed. This one's correct. So anyway, I'm going to rotate it 60 degrees, one of them. Rotate it another 60 degrees. So that's 120 degrees rotation. Rotate it another 60 degrees. And then you pop the right-handed down on top of the left-handed. And I've got it. Combined twin. To me, this is probably one of the rarest ones I've seen. So here it is. And this is this is not too ugly a quartz crystal, but it's kind of a yellowish. But notice on this face right here, it has top left hand, bottom left hand. So that's part of a combined law. All right, so the Japanese law, Japan law, that's what they call it because it was first classified in Japan. But anyway, this is at an angle almost 90 degrees, but not quite. I should have put the degrees on there, but I don't think I did. So this one here, Ray swears he didn't do this, but I think he did. I was up at Crown King. We were looking for quartz crystals, and he was walking along, and I'm walking along right behind him. And I think he took this out of his pocket and dropped it on the ground. And I found it. He swears up and down that didn't happen, but I'm pretty sure he did. But this is one of the first Japanese twins I found. That's pretty cool. I was really excited. Next one. Now this is, I've seen a lot of these. I think I bought this from Dave Shannon and Sons. But look at the striations when I go onto the back side. On the front side here, I want you to know you tell me whether it's right or left-handed crystal. Right now. So that would be a left-handed crystal. Now the striations on this one, notice how one goes that way and the other goes the other way. That's a twin. Now this is one of my favorites. I bought this on eBay. I bought it from someone in Tucson. I paid like $3.65 for it. It cost me more to ship it to Phoenix than it did for me to buy the crystal. This thing, if you take your two hands together, palms up, and put them in that configuration, that's how big it is. It is huge. I cannot believe I got it for that price.
That's worth a
Someone
trip to
obviously didn't know
Phoenix.
what they had. And I don't know why people didn't bid on it. They probably thought it was micro. I bought micro Japanese twins before, and I'm going, my God, I thought it was at least bigger than that. Well, this one was, so. Now this one
That's
I
worth
got.
that one was worth a trip to Phoenix. You should have driven down.
They should have driven down and got it.
Yeah, that was worth it.
I didn't know how big it was until I got it in the mail. It's like, oh my God, I bought this for that much money. So this one I really like too. I got it at one of the symposiums actually. And if you look, it looks almost like butterfly wings. I like to find a butterfly that would fit that pattern and have it butterfly fly off. But anyway, I took a picture of it. I just bought a little, I can actually hear it, my little turntable. So anyway, I got this one. I like it. I looked it up. I didn't know where it came from or nothing, but it's from Madagascar. So I think this one here, I took the picture from Mindat. That's it. That's a picture from Mindat. And the other one is mine. It could be the same crystal. Could be the same crystal almost. Really, really close. All right, so this one here, Ray found for me. This is a double Japanese twin. And what's interesting about it, it's hooked onto the hexagonal prism on two faces that are side by side, adjacent to each other. So the angle between the two Japanese twins is 60 degrees. I don't know where all that music is coming from. You must have been listening to something when I did it. So there's the first one. And there's the second one. That's pretty cool crystal too. All right, so unusual structures. Now, I thought I used to be able to rotate this one, but I can't find it. So anyway, but it's a tabby. It's probably half of a Japanese twin, actually. But if you even distort this thing, it still has those 120-degree angles between the prism faces. And this is called Fenster Quartz, and it has lots of air spaces in it. It looks like it's just been really smashed. If you look at one of the sides here, the one that's coming up, when I go around on the other side, it's all smashed in. It's gone through a lot of distortion. See it? You can see the indentation there. Fenster Quartz. And this is Fadden. Has these little white lines through them. I think these are from Pakistan, and I've been told that those little white lines are micro crystals of quartz. They grow first, and then the big quartz crystal grows over it. I've got some more of those I'll show you later.
Question on that.
Yeah.
Question. Would that be maybe considered an inclusion in a quartz inclusion in the quartz?
No, I guess it could be. I don't know if you consider quartz in quartz as an inclusion, but I don't see why not.
About almost the only one you could see as an inclusion.
Oh, I've got another one you can see.
Well, I mean, quartz is about the only one. Clear quartz.
Oh. Quartz in quartz.
Yeah.
Yeah. So this is a Fadden too, but the crystals are at an angle to it. That's kind of interesting too. So here, this is called a sea face. This is Amethyst from Four Peaks. And it's fairly rare to find these. Four Peaks has a lot of them, but I guess they're not too common around the world. It looks like someone took sea face. It looks like someone took a file and filed off the top of it. You could make your own sea face. Here's up close where it looks like it's been ground off. I don't know whether it's because the quartz crystal was drug across something else, during some kind of earth movement or what, but they're called sea faces. There's a lot of them up at Four Peaks. And here's cubic. This one, this is really an ugly crystal, but when you look at this one part of it right here, it looks like a cube, corner of a cube right there. I mean, it's just so perfect at one corner. So now here's another one. This is a Pecos diamond. It looks like a sugar cube. It's called Bach quartz. I think what happened is some crystal, some mineral dissolved out of a pocket or somewhere, and then quartz came in and filled it up. And the quartz crystal, this is a quartz crystal that came out of that vacant space that whatever the other mineral was. And it shows all the markings and everything. It's kind of interesting. Separating quartz. Quartz is not supposed to have cleavage. This thing does. You can actually see some of the lines in there. I think maybe it formed from maybe some kind of maybe a meteorite or something hit the earth and did that. Who knows? I don't know. Quartz doesn't have cleavage faces. Yes.
I've seen things like that. Most of them have turned out to be gypsum, but I can't always tell that. Are they moderately common or?
No, that's the only one I've ever seen.
Okay, then what I've got is gypsum. Thanks. I haven't tested it for hardness, so.
Well, I haven't tested it. I just went by the label. I guess maybe I should check it. I'll try and remember to do that.
At least see if a knife or something scratches it.
Yeah, it's pretty hard. It really is. Okay, let's see where I'm at. Okay, scepters. So here's a scepter. That's just a picture. Here's another picture of a scepter. And then here's one. I just did this one. It's amazing what you can do with your cell phone now. I bought this $10 turntable on Amazon a week ago, and I took my cell phone and I took this picture. I guess I shouldn't listen to the TV while I'm doing this. That one's gray. That color came out almost perfect. All right, so here's the one. This is from Vandenberg Mountain in Namibia. There's a face. This crystal is really all crusty and everything, and it is a scepter because the base is down there. But there's a window right here in the front of it, and that little white spot in the window, that's a little quartz cluster down inside of that thing. Little set of crystals down there that you can see inside. I think it's solid all the way through, but it's kind of interesting. It looks really pretty if you look at it.
I have another question from someone in the audience.
That's all right.
Where can we find pretty quartz in Arizona?
Find what?
Pretty quartz in Arizona.
Pretty?
Mm-hmm.
Pretty?
Yes. Yes.
You can go to Diamond Point. A lot of those crystals are pretty. I've got a couple of those I'm going to show you. I don't know. I don't know. You have to be lucky too. Also, I think there's some nice quartz crystals that come out of Washington Camp area. Except they opened that, and I've always wanted to go there, but they opened it and then they closed it back up. I still want to go there sometime. No, my dog's bothering me. Hang on just a second. I want to put her out. Come here. Go. So this is kind of a reverse scepter. Got a little bitty scepter on the end of it. And I've got another one. There's a one single crystal, and it's got two little scepters. It's doubly terminated inverse scepters. All right, so bent crystals. Here's another one of those spatins. And it's bent. You can see the bend in that one. This one's a little bit harder to see, but as soon as it comes around the corner, you can see it. It's kind of curved a little bit right there. Okay, come on, stop. Here's one. I think the reason this one's bent is because it was fractured and it rehealed itself. I call it the knee. It kind of looks like, oh, I don't know. I can't remember where the place is. Okay, so we saw that one. Now this one's kind of interesting too. As it turns around, look at the faces. It looks like the faces are kind of weird. So I decided, okay, so I need to look at this thing more. So I took a picture of it and did some some measurements on it, and the faces are off by that much. So what I think this one is bent, but it's kind of tilted bent with the crystals. Not much, but a little bit. You can see it. So I got this. Ray found this one for me at the flag show, and I think it came out of a little box of crystals. Maybe it cost $1 or $2. But this one is bent. You can see it right there, bent. You can see it right there. So here it is, this single picture of it. You can see that bend. That is the most bent crystal I've got. I like these weird things. Okay, this one is a penetrating quartz crystal. Yep.
John, we have another question. Oscar's asking, which quartz is most common in Arizona?
Which one's most
anything
common?
in particular? Yeah, anything in particular, or just whatever you find?
I think it's pretty much whatever you find. I mean, there's different quartz crystals around different places. Like Washington Camp, you can find Japanese twins. Diamond Point I've found in hydros. I've found phantoms. I found just regular crystals, inclusions. Diamond Point's a good place to go, except they got some limitations on when you can collect there. It's a fun place to go. All right, so this one is a tooth. Looks like a tooth coming out of this crystal. I found this down in Tucson during the mineral show down there. See how that's down into the big quartz crystal. Actually, I had to repair this. I knocked the end of that tooth off. I was so mad, but I actually found it, and it doesn't look too bad. But it is repaired now. Now here's a stacked one. I call it distress quartz. I think as this quartz crystal was growing, that calcite was forming too every once in a while, and so it formed in between the chunks of quartz, and then it was dissolved away. It looks like it went through hell. Interesting. I got one more interesting though, the next one. This one. I found this one I think I got it at the flag show. But you can see that it looks like there's something going on here, little lines on that one, and different places. Can you see my cursor? I'm asking you all questions.
I can. I think everybody else can see it better because their screen's bigger.
I'm just curious whether they can see the cursor because I'm pointing at stuff. But anyway, there's a little line there. So going on to the next picture, I lined it up so you can see it. Looks like something just sliced that off and then glued them back on, which I find really, really interesting. You can see that whole plane along there. It's cut right there. And I did a couple of them up close. There's the big crystal right there, how it's even got bevels on it. And this one here is just kind of sitting there. Looks like it's just sitting there like a rock on another rock.
We got a couple of yeses about the cursor.
Yeah, okay, good, because I wonder what I'm pointing and I'm talking and I'm going, maybe they can't see it, so. And you know, when I'm looking at pictures and things, I find other things. I'm looking at, there's some kind of crystal, looks like crystals growing on the side of that one. I don't know, I've never noticed it before. All right, so here's another one. This crystal was broke. These two crystals right here are about the size, each one of them, I could hold one in one hand and one in the other. Well, it broke. And this is the face that would go against this one. And they rehealed. You can see where they rehealed themselves, but they didn't heal themselves together. Kind of interesting. They must have been laying in a pocket with silica and it started growing on the broken faces. And this one I picked up at the flag show. I got this crystal here at the top left-hand corner. I pull it apart a little bit. What I did is I watered up a little piece of Kleenex and stuck in there and then put the top back on it. And then here's the other part right there, taken apart. So they match. I thought that's kind of cool. And here's a Herkimer diamond from Herkimer County, New York. They're just little quartz crystals embedded in the rock. I think they look better like this than when they're dug out of the rock. People have hands full of, oh, here's a handful of Herkimer diamonds. That doesn't mean anything to me. I'd rather see it in matrix. So here's one from Payson, Diamond Point. And I think I got this rock from the Leverites. I gave a talk for them one time. And so I set up a burette up above this and I dropped hydrochloric acid on it. And I dissolved all this out until I just had this crystal. There's another one up here. So that's a quartz crystal from Diamond Point. You can find, you can go out and find these just laying on the ground, or almost anywhere you dig down on the ground, you can pull up a quartz crystal. It might be an inch or two across, or it might be a couple of millimeters across, but they're everywhere. They're everywhere up there. Okay, this is one of my first double terminations. It's pretty ugly, but it showed both points and all the faces. Other than that, it's pretty ugly. So here's a double termination. This is a beta quartz. It's really nice. If it has 6 and 6, I don't know what you have, 12. I don't know what you call a 12-sided figure. Anybody know what a 12-sided figure is called? I should know that. So I call this a signpost. Notice it's pointing in 2 different directions. I think it rotates. There we go. Everybody see the black on one side and black on the other side? When I refigured this thing, that's what happened. I lost the part of my picture.
John?
Yep.
I got dodecagon.
Dodecagon?
For a 12-sided figure.
Oh, okay, dodecagon. I'll have to remember that. Thank you. All right, so here's one. Here's a signpost too. I got this from Ray, and he got it from one of his friends in Russia. The way it started out, you have this quartz crystal, and it's got red on the inside, a little bitty red crystal on the inside. It started out growing as red, and then to get the white quartz off the outside, you dissolve it in hydrofluoric acid, and then you come down to this part. You have to take it out before it eats it all away. But Ray can tell you the story about the guy that was doing the etching or dissolving with hydrofluoric acid. It does exactly what the warnings tell you it will do. Oops. Drusy Quartz. I thought this one would spin, but it doesn't. So you can just see how sparkly it is. I got another Drusy Quartz on down the line. Inclusions. So I found this one at Diamond Point. I really like this one. It's little, but if you watch it now, it's going to come around, and in just a second, right about now, everybody should see the phantom on the inside. So there's a phantom from Diamond Point. So this one's rutilated. It has a little wire in it. If you take this quartz crystal and you run your finger across the top on the prism, and you run it down the bottom, you can actually feel the wire. Just barely sticking out, but it's there. It went through it. But then if you go up really, you can focus in on it. And there's the wire. You don't see too much, but if I go to the next picture, you can actually find little bitty fibers on the end, even smaller than that wire. That's the wire we were looking at. There's these little bitty fibers in there. Just a couple of places. It's not full of them, just a few.
Have two questions.
Yep.
The first one is, what caused the red in that quartz?
The first one? My signpost?
Well, what caused the red in the quartz? The first question.
Yeah, okay, it's probably some iron oxide. Not sure. Ray could probably answer that better than me, but it's probably iron oxide.
Okay, thank you. The second question was, you're saying wire. Is that what do you mean by wire?
It's probably
like a man-made wire,
some mineral.
Ah, okay.
And it's only I call it wire because it looks like a wire, and you can feel the end of the crystal at the top and at the bottom.
Okay, just making sure it had not formed around some man-made wire. That would be quick and interesting.
Yeah, I've got one that's kind of like that though. All right, here's one. This is nice. It's related a lot. Real sparkly. So here's an amethyst crystal, and you can see these little sprays of rutile or whatever coming out at the top. Some of them have lots and lots of them. This one had a couple where I could just focus in on them, but you'll see some of them have lots of them in there. So I call this one the nose hair rock. You look down at the bottom, you see all these little pieces of something. If I focus in on that, they look like someone trimmed the hair in their nose and it fell down while the crystal was growing. Just a jumbled mass of stuff in there. What it is, I'm not sure.
I'm real glad I asked that question about the wire before that picture.
Before that what?
I'm real glad I asked the question about the wire before that picture.
So this one, if I rotate it and I got a bright light shining on it, you can see the point where 6 lines come together, right about there. Did it again there. You can see it. Okay, that's probably due to microfibers of rutile or something in the quartz. Oops. So here's one. Ray gave me this. This is a slice of a quartz crystal, and I think it's probably a stalactite or stalagmite, but look at the center of it. There's 3 lines across each other. I would venture to say this is basically about the same property that was in that one before that one. In other words, you can see the 6 sides, 6 areas there. Okay, and then hydro, this is water bubbles. This one here, this is a really good example, but it'll drive you nuts. I mean, this thing, I'm going to rotate it a lot. That bubble goes a long ways. Actually, there's microcrystals on the inside of that bubble, inside the water, that move around. So I've got another one. It's not quite as bad as this one. So this one does the same kind of thing, but it's not a bubble. It's a piece of carbon. I'm pretty sure it's in liquid, because if it wasn't, it would fall faster. This just kind of glides to the next place. All right, here's an inclusion. This looks like you know how you take Oreo cookies and you take off one slice, one of the outside of the wafers, and then you eat the cream on the inside? Here we go. That's my Oreo cookie. So here's some iron oxide inclusions. They're in the outside surface. I think that's what's causing this. I got another one that's much bigger. This one here barely fits in the palm of my hand, and that's iron oxide or whatever on the outside. If you turn it over and look at the bottom of it, it's like a scepter, but on the inside it's turquoise. I mean, not turquoise, amethyst. I wish it was turquoise. Amethyst on the inside. And this one is Snowball. This is from Crown King area. And look, this looks like a snowball in there. There was a guy from Flagstaff doing research on it. I never did find out what he decided was in there. And this one just looks like a chunk of, actually, you know, this one looks like maybe a coronavirus in it. Remember the picture of a coronavirus? So start to look, see all the little bumps on the thing? That could be a coronavirus nodule that's locked up in a quartz crystal. Got to make light of it a little bit.
We have another question, John. Is gold associated often with clear crystals?
I've got some gold that's on crystals. I've got the one I've got gold with looks like it's just on the outside of the crystal, and I think it's more like not a clear crystal, frosty crystal, but it's just loose gold. And I got another crystal. I was trying to photograph it, but it doesn't look real exciting. But it's a Smoky that's got gold wrapped around on almost all the sides of it. I got it at the flag show, probably for a couple of bucks. And I got to looking at it really close, and there's gold on it. I've even got agreement that it's gold. We just don't know whether the gold's been put on it after the fact or whether it's part of the crystals. So I don't know if it makes any difference whether it's clear crystalline, or whether it's smoky or what, or massive. You could still have the gold with it. I guess that I guess that answers it. This is just a.
Thank you. Yes, thank you.
This one is just a quartz crystal with a chunk of carbon in it. So I don't like to buy prepared crystals like that, like the big Japanese twin. I could polish off the top and edges of that and clean that one off that I got in Tucson. I don't like to do that. I usually keep them just the way they are. This is a little crystal of something inside of this, but I got it. I think it came from China, and they take these crystals and they polish them up to make necklaces out of them. So, but I could see that real good, so that's the reason I bought it. Now here's another one from China. This is a pretty good doubly terminated crystal. It's not very pretty, but it's got all the sides and all the points on it and everything, all the faces. And on the inside, you can kind of see the shape of a diamond in there. That's probably when that part of the quartz crystal was growing. There was some carbon around, and so the carbon is incorporated into the crystal. So they almost look like little crystals of carbon on the inside, but they're not. They don't look like they're pure carbon. They're just carbon in there. Ought to do carbon-14 dating on these. So this is one of my favorites too. Notice there's a hole in this, and this was made for a necklace, but it's not going to be a necklace. It's in my collection. A rhombohedral type structure, polyhedron. That's what I want to call it. Polyhedron. It's not quite cubic, but it's kind of offset a little bit. And at first I thought it was some kind of metal in there, and then the more and more I thought about it, I think the reason it looks shiny kind of is because of the interface between the quartz, and I don't think there's anything in it. I think it was like a calcite crystal that dissolved away. I mean, I could be proven wrong, but I don't want to cut it open to find out either. So it's pretty cool. It's a whole polyhedron in there, kind of cubic, but not quite. And here's some little vacant spaces. These are kind of interesting. Did shine a light on them. You can see the structures just by looking at what happens when I shine the light on them. There's 3 of them in there, and they're probably just vacant spaces where some other mineral was there, and then they dissolved out. You can see it really well there. It's kind of interesting. Tribolumenescence. You can take quartz and rub a piece of metal or probably another quartz crystal against it, and you get something like this. You can see the light shining through. That's interesting too. I think they used to use quartz for old muskets too. So maybe that's kind of related to that too. Crystalline forms. All right, so these are Smokies and Morions. This is a Smoky. Tell me what kind it is. It's a left-handed what? Start that over. I didn't want to start over. Left, left, left. That already tells you what it is. Left-handed Dauphine twin. This one is this is a Morion. It's really, really dark. I think maybe it was found around. It was hatched and lived around something that was radioactive. I've heard that radioactivity have a tendency to make these dark. All right, so this is one of the first quartz crystals I I took video of years ago. And so it's important to try and get them centered on your turntable. This one will drive you nuts. It's kind of, it looks like it's been fractured and healed itself. Look how it's all over the window. Left-handed, Dauphine twin. This just moves everywhere. If you don't get them lined up right, it's like, I keep my head straight watching this thing. I keep it in there just to remember what it's like. And this one looks pretty royal, but it's a old quartz crystalline score. Rose quartz. So I've got a couple of these. This is in my collection. It's not very big, thumbnail size almost, but you can see the pink. Finally, I outdid myself and I bought this one. These are actually crystals. You can see two crystals on the back part here. Another one. These are all crystals too. They're not quite as sharp as the others, but it's really intense pink. That's what I was trying to get the color. This is the color of it down here, rose quartz. And it's natural. Pink, very pink. Even this up here is fairly pink, but my light was kind of fading it out, bleaching it out or whatever. Didn't bleach it out permanently, just overshadows it or something. That's probably the most expensive mineral I have in my collection right now. So here's an amethyst. And it's interesting because three sides are amethyst color and the other three sides are white quartz. Purple, purple, purple. It's not very pretty. White quartz, white quartz, white quartz. It split itself half and half on this crystal. It's interesting how it follows those lines. Very interesting. Here's another one. This is not very good. This one's glued onto the platform. That's the reason it's tilted. I got it on my rotator and I tried to get it so it's lined up so it doesn't go out of the picture there. But I want you to look at the zoning that's up above. So purple, purple. Now if you look, you can see a white area, clear zone, and then you see the zone line, another white area, another zone line, purple. So they have a tendency to do some weird stuff like zoning and stuff like that. It's just strange. That's what I like about quartz. There's so many different things that are, so many weird stuff about it. So weird. Here's a citrine. It's a fake. Usually they'll take smoky crystals and heat them up and make them into citrine. I haven't got a real good citrine crystal, which I need to get sometime. I've got some that are kind of weak, but it's not real dark yellow. And then here's a fake Morion. A lot of the dark ones that come out of Arkansas, they put them in a nuclear activator or something, and they can make them dark. Fake. So here's synthetic quartz. Now, if you look at this one at the end here, see the those are two little pieces of metal, and at the other end there's another two pieces of metal. What they do, they put this in these two electrodes in molten quartz, and they let the quartz crystal grow between the two electrodes. This one's probably 3 inches by 3 inches by 6 inches, something like that. It's a big chunk of quartz. Quartz used to be really, really important back in World War II and probably World War I when they were making radios, because they were looking for the frequency that quartz could promote. And they were looking for quartz everywhere. And then they learned how to make it, synthetic quartz, and then it wasn't so important to find quartz crystals anymore. So this is massive quartz. I call it the tooth. I don't think it rotates, but it's just a big chunk of quartz sticking on here. It's not very big, thumbnail size, but it shows the massiveness. There's no crystalline part to this. And I found an arrowhead that's made out of quartz. You can find arrowheads that are made out of quartz. Indians were real good about being able to work this stuff. And this one I call the finger. And it's also a faden. Next one I have, this is a flower. So if you rotate this, it's really pretty. And there's little bitty spots on it. That's some mineral. I think it might be malachite or Priscola or something. Oops. Come on. We're ready to go. Yeah. And this is quartz crystals with Drusy Quartz on the top of it. If you look at it long enough, you might think it's snowing. And the end. So going on to the next one. This is my collection. Almost everything you saw is mine. And then I had a lot of help from Ken Costello. He used to work at Mesa Community College. I think Ray used to have a lot of help from Ken Costello. But anyway, he's retired, and he helped me a little bit on this because some of the videos were so old, AVIs, that I couldn't even get them to work. So guess who I called? I called Ken, and he helped me get through some of these things. Now I've got 3 more quartz crystals here. They're not mine. Obviously, they're not mine. They're Jeff Schofield's photos. You look at this one. This is a quartz Dauphine twin. You can see it. That was collected in Arizona. I think these are relatively new finds. So this is from the Santa Teresa Mountains in Graham County. It belongs to Cy and Ann Fraser, I think. I can't see it. I got something stuck on my way here. Real pretty. Here's another one on fluorite. This is again from Santa Teresa Mountains in Graham County. This is Dick Morris collection. Again, Jeff Schofield took the picture. And the last one is quartz with native copper. It's from the Ray Mine in Pinal County. It's in Les Presnick's collection. Again, Jeff Schofield took the picture. You can tell that they're his pictures because mine look like crap compared to this. So I'm done. That's it, finally.
Well, great. That is really fantastic. We have one more question, I think, for you. When you cut quartz, does it break apart along the planes of the quartz like a diamond?
No, it doesn't have planes. Actually, I think I think when you try and break it, I don't know, shatters or concordial. I don't know, breaks apart with concordial fractures or something like that. But it won't. You can't plane cut it. But you can cut it in 2 with a saw. I don't do that. I like to keep them. I like a la natural myself. So
I do that. That's a mineral collector instead of a gem collector.
Actually, I've got a cabinet now that I'm trying to sell a few of my old stuff out of, and I'm thinking about drilling holes in some of the small quartz crystals and trying to get some people that shop there to buy them so they can make their own necklaces. So I may start drilling a few holes in them.
Okay. Let me just make sure if anybody has a question, you can ask the questions in the YouTube comments if you do it quick, so we can get John to answer them before he has to go. And hopefully,
I'm going to go have a beer. That's what I'm going to do.
You deserve one. Yeah, you can't. I didn't tell everybody you were. I didn't tell everybody you were running from class to here.
I've been going since 3 o'clock.
But I don't see any more questions, so I will let you go. And I thank you very much. This is wonderful. It was terrific.
It was good. You know, it was good. It's good for me too because I need to get it back in par. So I need to get it cleaned up a little bit.
A question has popped up. How old do we think the quartz from Graham County is?
How old?
Yeah.
You mean when it was collected?
Formed, I think.
Oh my God. Well, there's an expert. There's an expert in the room. You should direct that question to Ray.
Well, he's not able to make comments.
Oh, he can write. He can write. He can type you.
I'll try and get an answer for you.
I don't know.
Well,
I have no clue. I don't think it takes. I don't think it takes that long to grow a quartz crystal. You just have to have the right conditions. But
I remember something about most of the quartz in Arizona being about 73 million years old. So
I think that's that might be a little old though. I'm not sure.
Maybe it was 53. I have it somewhere. I will look it up and answer the comment as soon as I find that.
Would you send it to me too?
Sure. Maybe I'll make a post about it also, so everybody can get the benefit of that. All right. Well, thank you very much, sir. I really appreciate you coming on.
Oh, it was my pleasure.
And I hope you have a great rest of your evening, and I will wrap things up here. I'll say goodnight to you, and I'll wrap things up and say goodnight to everybody else.
All right. Sounds good.
All right. Thank you.
Night.
Night. And thank you all. This has been, in case you didn't know, this has been the September meeting of the Pinal Geology and Mineral Museum and the Pinal Gem and Mineral Society. And that's about all you need to know. This has been John Weide. My name is Bob Hole. Next month, please remember, we will have on October 21st, Dr. David Gillette, formerly of the Museum of Northern Arizona, talking about gomphotheres here in Southern Arizona. A really good paleontology talk as part of our celebration of National Fossil Day, which is on the 14th. We'll have some other stuff. So thank you very much. Have a good night. I'm going to end the broadcast very, very quickly.